Hi, everybody. It's Thursday, January 7th, and for our math mini lesson today, I'm simply going to review the different shapes and different things that we've talked about through this week so far. Your guided practice for today is kind of a continuation from yesterday. You're going to finish your IXL CC2 for guided practice. So if you've already done it, if you've already gotten your SMART score to a 100, then good, you're finished. So today, again, is going to be a bit of a review, and then tomorrow you're going to have a short quiz over the week and the things that we've learned. Okay, so feel free to pause this video, draw out the different shapes, think about things, go back, play it again, backtrack a little bit until you've reviewed and you understand things fully. So the first thing we talked about were what we call two-dimensional shapes. And basically, a two-dimensional shape is flat. I can draw two-dimensional shapes on a piece of paper. This shape, it's not really popping up though, is it? Let's see. If I can get, there we go. So this shape is a triangle. It's flat. I can take out a piece of paper, I can draw it, I can cut it out, and it has two dimensions. It has a length and it has a height. Okay. So we talked about different shapes, and I'm going to pull this one up and I'm going to see if I can add a different shape. That shape has three sides. We talked about sides, and it has three vertices that you see where those white dots are and where the sides come together. We also refer to those as edges when talking about two-dimensional, and also we'll review three-dimensional in just a minute. Okay, I'm next going to pull up a different shape here. As you see, there is a rectangle. It is also two-dimensional. I'll change it to red. It is a two-dimensional shape. Again, I can draw and cut out a rectangle on a flat piece of paper. It has a length and it has a width here. So it has four sides and four vertices where those sides or edges come together, as you can see by those white dots there at the end. Another shape that we talked about as far as two-dimensional shapes go is this shape here, and I'll change its color. We'll make it blue. Okay, this is a two-dimensional square. Again, a square has four sides, kind of like a rectangle. They both fall into that category and they share that attribute, but a square is different because all four sides of a square are exactly the same length. So they must be the same in order for it to be considered a square. Okay, but it does have four sides like a rectangle and four vertices like a rectangle. So they do share those attributes. Okay, so we talked a lot about those two-dimensional shapes. I could put up a couple of more two-dimensional shapes just for practice. Here's another example. This shape has five sides. I don't know that we talked about this one earlier in the week, but it's just another example of a two-dimensional shape. And a five-sided shape is what we call a pentagon. It has five sides and it has five vertices, as you can see. Okay, all of these shapes are what we call polygons. Polygon is just a fancy word for a shape with many sides. I could put up other examples. You may have heard of an octagon or a hexagon. Those are all other examples of polygons. All of these are polygons because they have many sides, different numbers of sides. Okay, so when I refer to a polygon, again, I'm just talking about a shape, a two-dimensional shape. Poly means many. And I can even see if I can add that word. Oops. So polygon is a word that to describe all of those. Another different kind of shape that we talked about is a three-dimensional shape. And a three-dimensional shape is different because it's what we call a space figure. It takes up space and it's not flat. Okay, you did a Flipgrid assignment earlier in the week where you try to find examples of space figures that take up space. They have a length, they have a width, and they have a height. So that's why it's called three-dimensional, because it has three dimensions. A dimension is a measurement, a length, a width, and a height. So this cube was a good example of that. So as we review what we talked about, see if I can pull it up here. We'll do I'm going to put it into a prism, but we're going to make an example of a cube. And I know a cube has all of the same dimensions. So we'll see if we can make that happen. Okay, as I pull up my 3D shape, here it is. Okay, I can turn it to kind of show you the different sides and show that it does have different, or space. It takes up space. This cube that you see kind of looks like it could be made out of glass. It's see-through, so you can look through it and see all of the sides that make it up. We talked about how a cube has faces, and it has 6 of them. A face is the flat surface that you see, and I can turn this cube to have each face facing me, that I'm looking at it directly. So when we count the faces, we also have to make sure we count the sides that we don't see. This cube here is a good example because since it's see-through, I can definitely see all 6 faces. So a face was a good word that we use to describe this cube. This cube also has edges where the faces come together. This cube has 12 edges, if you count them all, including the vertical edges here, and vertices. A vertice, or a vertex, I should say, is where the edges come together and meet, kind of like a point. This cube has 8 vertices. So those are all, we use the word attribute of three-dimensional shapes. They have faces, edges, and vertices. And as I pull up maybe one more example, I'm not going to do them all today since, again, this is a review, but we, talked about different shapes that you see. I want to pull up this three-dimensional shape called a pyramid. And I can see as I flip it around that it has, how many faces do you see? Figure it out? If you said 5, you're correct. It has the rectangular base. The base is what the shape sits on. And then it has 4 faces that I can turn and see. So 5 total. How many vertices do you see? Again, I have to count the 4 corners here, plus the one where all of the edges meet at the top. So it has 5. Okay, and as far as edges go, I can see as I turn it, trying to get it to be a good angle to count those edges. Let's see. I'm going to just leave it like that and count 1, 2, 3, 4 vertical edges plus the base. 5, 6, 7, 8. So this pyramid has 8 edges. So that's kind of a review of our week and 2-dimensional and 3-dimensional shapes. Next week, we're going to get into a couple of other some other vocabulary words and ways to describe the attributes of these shapes. Have a great day.